everyone, welcome for this session. In this session, we are going to discuss about the power transmission by shaft, which is the activity of the torsion equation, which is already discussed earlier. Torsion equation already discussed is T by J equal to tau by R, which is equal to C theta by L. In this session, we are going to have by having the torque, how the power is transmitted. Okay, if a shaft is rotated, okay, a shaft having the shaft diameter as well as the length we are having. The shaft is rotating at a particular speed. The speed is taken as n in terms of RPM. So you can rotate about 1000 RPM. And how we are going to find the power transmission. So the torque produced by the force acting on that is equal to around 1000 Newton meter. If it is given, how can we find out the power transmission? So power transmission generally that is to be found out by using the equation 2 pi nt by 60. 2 pi n into torque divided by 60. That is the basic power transmission equation. Where n is, I told you, it is the speed in RPM. T is torque, which is force into radius. If it is given the diameter as the force acting on it, we have to find by torque that is equal to force into radius by 60. And I want to know that one question, why this 60 is coming here. It is nothing but torque or shear speed is in terms of revolution per minute. That is the RPM, revolution per minute. But I know that the power generally it is taken in terms of unit as watts. So 1 watt that is equal to 1 joule per second or 1 Newton meter per second. So 1 Newton meter equal to 1 joule. So 1 joule per second is equal to 1 watt. That is the general basic fundamental equation. But I am carrying revolution per minute. Okay. So I will get Newton meter. Okay, torque is Newton meter into speed. Speed is revolution per minute. Actually, revolution does not have any unit at all. So we have only Newton meter per minute only. Okay. So Newton meter per second is the. Okay. So this will come as joule per minute only. So I am using without the 60, that is joule per minute. So it is not equal to, this is not equal to what? What I am going to say, instead of minute, okay, instead of this minute, I am going to replace this meters seconds. How much seconds? 60 seconds. Okay, so joule per second now, that is what? The 60 comes here in the denominator. Okay, so 2 pi nt by 60. Why I am saying is that is the formula, but in case the speed is given directly revolution per second, you should not use this 60. That is the main purpose to indicate why the 60 is given. Because in case of problem, that speed of the shaft is given in terms of revolution per second, we should not take directly whether we have to convert it to RPM, otherwise we have to skip this 60. That is the purpose I am mentioning here. Okay, like that you can have it. And one more thing, here the torque point of view, they can give one thing. Okay, here they are giving the maximum torque, which is equal to 20% more than the mean torque. Okay, they can give a torque which is 20% more than mean torque, like that it will be. Okay, so we can have this mean torque as T mean. Okay, so here I am having two types of torque. One is maximum, another one is mean torque. So I already told as per the torsion equation, T by J equal to tau by R equal to C theta by L, where T is the maximum torque. So this T max comes here. Okay, and this T mean, where does T mean come? So power transmission P equal to 2 pi N T by 60. Here this torque is called mean torque. So where we are going to apply the torque mean torque as well as the maximum torque. We should not apply maximum torque. If it is classified maximum mean torque, okay, now we are having two different torque. We should apply only mean torque here, not maximum torque. But we have to always use the T max. So if it is T max, this T max, okay, like that you can apply. Okay, so I am going to find how this T max. So T max equal to, if it is 20% or more than the T mean, then this is 1.2 times. That is 120%. That is 1.2 times T mean. Like that I can have a one relation. From that I am going to find from the maximum equation. Otherwise I am finding by using the mean term, that is the power transmission. If I am having, I am just applying this formula, I am getting the T mean value. I am going to apply T mean here, then I can apply maximum torque. Because here also the same question to find the diameter of the shaft for hollow shaft or solid shaft only they are going to ask. Okay, only thing is here I am going to discuss power transmission, how to use this mathematical expression, and if two different types of torque, that is maximum torque or mean torque, it is given, how to take. Okay, that is there because sometimes we will be in a position to confuse why it is given maximum and mean and 20% or 30% higher. Okay, at that time where we have to apply, that is very, very important. If we don't know, we will get a wrong answer only, even we know the mathematical formula for the particular problem. Okay, I think you will get my point. Other things are same. To find the diameter by using the simple torsion equation to find the torque of to find the diameter of the shaft. Okay, then we can apply. But the thing is, just to get the value of T max, how I can get the value? First, you have to find get the mean torque from the power transmission, because it is at that point this power can be given. Power is given in terms of kilowatt or watt. Okay, and you can apply here, get the mean torque. You apply here, you will get the T max. Then you can apply in the torsion equation. Then you can find the diameter as an area. Okay, I think you have got a point. Okay, you will have another topic in this. Otherwise, you can solve a problem in this torsion equation or power transmission equation to find the diameter of the shaft as well as the hollow shaft. Then compare the hollow shaft and the solid shaft. Which one is beneficial or efficient, whether hollow shaft or solid shaft? I think hollow shaft is beneficial as well as the weight reduction and how it is. So by having the problem, we can prove that how much it will be beneficial than compared to the solid shaft. Thank you.